This video works through the Module 7 review. Question 1. Evelyn runs around the track. The table shows how long it takes her to run different number of laps. How long would it take Evelyn to run 10 laps? So we can see that in 8 minutes she runs 4 laps. So I can think, what is my unit rate? So to get unit rate, I'm going to take the total time, 8 minutes, in this first ratio, and divide it by the total number of laps, 4 laps. And when I do that, I can see that means it is taking her 2 minutes per 1 lap. So if I need to figure out how long it's going to take her to run 10 laps, in my question, I'm going to set up 2 equivalent ratios, so my 2 to 1, my unit rate, and then I'm trying to solve for 10 laps. So I need to figure out this missing number. So I can think 1 times 10 equals 10. So 2 times 10 will give me my answer. 2 times 10 is 20. It will take her 20 minutes. The graph below shows the distance an object moves. According to the graph, how many meters did the object move after 15 minutes? So I'm going to look down here where it says minutes, time in minutes, and I'm going to go to 15. Here it is. And I need to just follow 15 up to see which distance it matches up with. And when I go over to the side where the distance is, I can see it matches with 15 meters. Solve using a unit rate. Jim can run 4 miles in 40 minutes. How many miles can Jim run in 55 minutes? So I'm going to get that unit rate first. So 40 minutes, 4 miles. That means Jim is running in 10 minutes, 1 mile. There's my unit rate. I'm trying to figure out how to solve for 55 minutes. One way you might want to do this, now that you know your unit rate, is you could create a table. So I can just draw a quick little table comparing minutes to miles. I'm going to start with my unit rate, which I know it takes him 10 minutes, come on pen, to run 1 mile. And then I can keep going with that pattern. So 2 miles, that would mean 20 minutes. 3 miles, that would mean 30 minutes. There's my ratio from the problem, 4 miles in 40 minutes. And then 5 miles in 50 minutes. I'm going to leave 1 blank, and I know that 60 minutes would mean 6 miles. So what is going to fit in the middle here? 55 minutes, that's what we're trying to solve for. So what is halfway between 5 and 6? Well, that would be 5.5 miles. He'd be able to ride 5.5 miles. We know that for every 10 minutes, it's 1 mile. And so he runs 55 minutes. So we have 10, 20, 30, 40, 50 would be 5 miles. And then another 5 minutes, so another half a mile. Solve using a unit rate. The scale on the map is 2 inches equals 30 miles. If the cities of Newport and Capeville are 4.5 inches apart on the map, what is the actual distance? So I'm going to get my unit rate first. I have 30 miles is 2 inches, so I want to know how many miles per 1 inch. So I'm going to divide both of these by 2. That gives me my per 1, which 15 miles per 1 inch. Okay. And then I'm going to break this down for me. So I have 4.5 inches. So 4.5 inches is like having 1 inch, 1 inch, 1 inch, 1 inch, and then another half of an inch. So for each of my 1 inches, we know that's going to be 15 miles. And then my half of an inch has to be half of 15. Half of 15 would be 7.5. So if I put all of these distances together, I end up with 67.5 miles. Number 5, solve using a unit rate. A recipe calls for 6 cups of flour and 18 cups of water. How many cups of water should be used with 4 cups of flour? So I'm going to get my unit rate again. Here's my 18 cups of water. compared to 6 cups of flour. So that means my unit rate, so I'm going to get per 1 by dividing by 6, is 3 cups of water per 1 cup of flour. So now that I have that, this time I'm going to use that to set up a proportion and solve for my unknown number. So I'm trying to solve for the 4 cups of flour. So now I'm going to think, okay, 1 times 4 equals 4. So to get my amount of water, I'm going to do 3 times 4, and that is 12 cups of water. A coffee mug would hold about 10 blank. So in your A1 notes, you have these benchmarks, and so we can think about what would make sense. A coffee mug, would that hold 10 gallons, 10 fluid ounces, 10 pints, or 10 quarts? In this case, fluid ounces makes the most sense. Question 7, the width of a door is about 1 blank wide. Choose 2 answers. So if you look again back to your A1 notes, you have these benchmarks, and we can see that the width of the door was about 1 yard and also about 1 meter. 1 yard and 1 meter are very close together in size. Question 8, use the chart. You do not need to write the unit. So 12 meters equals blank centimeters. So again, we're going to use kind of our benchmarks in our conversion chart. This time we're going from large to small. And remember that little tip, horse to fly, you multiply. So we are going from a horse, a bigger unit, to a smaller unit. And so we're going to take our number we have, 12, and we're going to multiply. Horse to fly, you multiply. And I have to look at my chart to figure out, oh, okay. So 1 meter equals 100 centimeters. So for each meter, I'm going to have 100 centimeters. So when I multiply, I end up with 1,200 centimeters. Write an equivalent ratio to find the answer. You do not need to write the unit. So 2 quarts equals blank fluid ounces. So I'm going to use that multiplying trick, multiplying trick again. So I have large to small, so I'm going from large to small. So horse to fly, I'm going to multiply. This conversion isn't in your chart, so we are going to figure out this using right here, this tip. So 2 quarts, we need to convert it to fluid ounces. Every quart is 32 fluid ounces, so we're going to take 2 times 32, and we will get 64 fluid ounces. A backpack weighs 128 ounces. What is the weight of the backpack in pounds? So this time we're going from small to large. So we're going from ounces to pounds. So this small to large is that fly to horse, divide, of course. So we're going to start with that number we know, 128 ounces. Then we look in our chart and we can see for every 1 pound it takes 16 ounces. So I'm going fly to horse, divide, of course. I'm going to divide by 16. When I divide, I end up with 8 pounds. Ryan drew a line on the sidewalk that was 8 feet long. Gina drew a line on the sidewalk that was 4 yards long. Ryan wanted to make his line the same length as Gina's. How many feet did he need to add to his line? So we're just going to write out some notes here. We know that Ryan has a line that's 8 feet. Gina has a line that's 4 yards. We need to change this into feet so we can figure out how many feet Ryan needs to add to his line. So this is, again, if we look at it, we're going from large to small. So horse to fly, we multiply. So we're going to take our number that we know, 4 yards. And then for every yard, it is 3 feet. So 1 yard equals 3 feet if you look back in your chart. And so I have to multiply 4 times 3 to figure out, okay, Gina's line is 12 feet long. But you can see that's not an answer choice because my question is, how many feet did Ryan need to add to his line so it's equal to Gina's? And so right now his line is 8 feet. We need to figure out what does he need to add so that it is 12 feet. So 8 plus 4 will get him to feet. Ratios that name the same comparison are called equivalent ratios. So the ratio 1 to 2 is equivalent to the ratio 3 to 6. A math statement that two ratios are equivalent is called a proportion. So when we write out 1 to 4 and make that equivalent ratio of, 2 to 8, this is now called a proportion.